All right, pre-algebra students, we are moving into our final lesson about proportional and non-proportional relationships. In this one, we should be able to compare and contrast proportional and non-proportional relationships in tables, graphs, and equations. So make sure you're following along with your notes and let's get started. So let's first compare side by side proportional and non-proportional relationships in tables. There are some things we need to know here. In a proportional table, the ratio of y over x, or the y variable divided by the x variable, it should be constant or the same throughout the table. It has a constant of proportionality or unit rate, and when x equals 0, y equals 0. So let's take a look at this table comparing time in minutes to distance in feet. I know that my y variable is going to be distance because my unit rate, if it has one in this table, will be feet per minute. So time is x, distance is y. So we want to take a look at the ratio of y over x throughout this table. So let's start from comparing 6 feet to 2 minutes. The ratio of 6 over 2. Let's see if it's equal to the ratio of 12 over 4. And let's see if that is equal to 18 over 6. Now, if all of these ratios reduce to the same thing, this table is proportional. So 6 over 2, I can reduce that to 3 over 1. 12 over 4 also reduces to 3 over 1. And 18 over 6, if we divide the top and the bottom of this fraction by 6, we're also going to get 3 over 1. So all three of these ratios are the same, which means that this table is proportional. You can also tell if you have an x value of 0 matched with a y value of 0. The constant of proportionality in this table is 3, or 3 over 1. That means this table has a unit rate of 3 feet per minute, 3 feet per 1 minute. In a non-proportional table, the ratio of y over x is not constant. So again, we have x and y. And also in a non-proportional table, when x is 0, y cannot equal 0. So for example, in this table, we see x is 0, and at the same time, y is 4. So automatically, this tells us this is not proportional. But let's take a look at the ratios anyway. Let's compare feet per minute. So we've got 10 over 2, we have 16 over 4, and we have 22 over 6. Now let's try to reduce these ratios and see if they're the same. 10 over 2, if we reduce that ratio, or really just divide 10 by 2, we're going to get 5 over 1. If we reduce the ratio of 16 over 4, that would be 4 over 1. So automatically I know these ratios are not the same. And then 22 over 6, if I divide the top and the bottom by a common factor of 2, I'm going to get 11 over 3. So these ratios here, 5 over 1, 4 over 1, and 11 over 3, they're not the same. So this is a non-proportional table. Let's look at graphs, comparing proportional and non-proportional graphs side by side. They do have one thing in common, and that's that the graph forms a line. Proportional and non-proportional relationships are linear. Back to the proportional side, a proportional graph passes through the origin. It will always pass through the coordinate 0, 0. And because of that, the y-intercept, where the line crosses the y-axis here, will always be 0. So here's the y-intercept. It is passing through the origin. This graph is proportional. In a non-proportional graph, the graph does not pass through the origin. Basically, that means the y-intercept is anything except for 0. So if I look at this particular graph, I can label the y-intercept. The y-intercept on this graph is -2. So since it's not passing through the origin, it is non-proportional. And let's look at equations, proportional versus non-proportional equations. So in this case, a proportional equation is written in the form y equals m times x, where m is the slope. The y-intercept in a proportional equation is 0. So technically, here's your equation y equals mx. This is technically y equals mx plus 0. The y-intercept is always 0. So here's an example of an equation that's proportional. Y equals -4x. -4 is the slope. And the y-intercept is 0 because we're not adding or subtracting anything at the end of our equation. It's just y equals -4x. In a non-proportional equation, these are written in the form y equals mx plus b, where m is the slope of the line and b is the y-intercept, where your line crosses the y-axis. The y-intercept in a non-proportional equation is anything except for 0. So it could be 0.5 or -1000. As long as the number is not 0, this is a non-proportional equation. So here's our example, y equals x minus 2. In this equation, the slope is 1, right? There's an invisible 1 in front of this x. So the slope is 1, and the y-intercept is the number being added or subtracted at the end, and that's -2. I see x minus 2, y-intercept is -2. So that's what makes this equation non-proportional. For additional practice with comparing and contrasting proportional and non-proportional relationships in all of these forms, try out questions 1 through 8. So that is it for this pretty quick lesson. Make sure you're trying out those additional practice problems to confirm your understanding of these concepts. Check your answers with my filled in notes and ask for support in Math Help Desk if you need it. Thanks again for watching. Have a great day.